we're going to do and go over lesson 14.4 on three-dimensional figures. And if you want to, feel free to open up your math books to page 624. On that page is a wonderful reference that we'll also have up here as we go over this. All right, but before we begin, let's do a quick review over area, finding area. As you know, that when we find area, we're going to take length times width, or base times height. So here we know that we have a length of 11 miles and a width of 8 miles. So you would take 11 times 8, and you would get 88 miles. And again, we're talking about area, so it's squared, our unit of measure squared. The next example, they don't give us a figure, but they give you the dimensions. So if you have a length of 25 and a width of 42, that's going to look something like, well, that's going to be a strange one, isn't it? Because it's going to be something, I don't know, maybe something like this, but maybe like that. But anyway, we're just going to plug in these numbers. This is going to be 25 inches, and this is going to be 42 inches. And then when you multiply those two together, and you can use a calculator. For something like this, I would definitely recommend using a calculator. If you want to do double-digit multiplication and then check your answer with a calculator, that's a good idea too. So you'd have 1,050 inches, and again, it's area, so it's units squared. Here we have some decimals, 8 and 6/10 centimeters, and a width of 8 and 6/10 centimeters. So what does that tell you about that particular shape? It's probably, or it is a, what, boys and girls? Square?
Square.
Yes, square. All right, so you would take those two decimal numbers and you'd multiply them together, and you'd get 73 and 96 hundredths centimeters squared. All right. So today we're going to identify characteristics of three-dimensional figures. I'm going to skip over this, but this is the reference that you should look into your book for as you're completing some of these questions. Here you have a rectangular prism, and a rectangular prism is going to look something like these right here. You've got some rectangular prisms. You have 6 different faces, and I'm going to pull out my Kleenex box. Okay, each one of these sides is a face. Okay, you've got the top, bottom, the front, and the back, and then the sides. Okay, this is a rectangular prism. A triangular prism. Do we have that? Is this it? I better make sure this is our triangular prism. Here we go. A prism that has triangular bases. Here you can see the triangle. Oh, we're getting a close-up view. All right. There it is, and this is a triangular prism. Now, when we're talking about a cylinder, everyone has a can of soup at home. Okay, you can think of a cylinder as like a can of soup. You have 2 congruent, remember congruent means the same, circular bases, one on the top and one on the bottom, and it has a curved surface that connects at the bases. And so your soup cans, things like this, that would be your cylinder. Okay, and then my favorite, because I like ice cream, is going to be your cone. Okay, so just think of that, the cone shaped as like your ice cream cone. You have one curved surface right here, okay, and then you have one vertex, that point at the top. Okay, that is your cone. Okay, so when we're looking at this, it says describe parts of the figure to the right that are parallel and congruent, and then identify the figure. If we look at that cylinder, you have these 2 circular faces that are parallel and congruent. This side is congruent and the same as this side, and they're parallel to each other. Okay. This would be one face, and this would be another face too. What else do we know about it? The figure has no edges. When we're talking about edges, we're talking about things like this, where the 2 faces meet. okay? These straight lines where the two faces meet. That would be considered an edge. Okay, so the figure, as we said, was a cylinder. Looking at this figure, you have 6 faces, right? And this face would be parallel to this face, and so on. We know that this is kind of like our Kleenex box, and that is an example of a rectangular prism. Okay, describe the parts of the cereal box that are perpendicular and congruent. Okay, then identify the shape of the box. So perpendicular, what we remember about that is when things are perpendicular, they're going to form those 90-degree angles. Sometimes we talk about like this face is perpendicular, the side would be perpendicular to the bottom face. It forms a 90-degree angle. And sometimes we'll say, well, this face is adjacent or next to this face, okay? So when we're talking about perpendicular and congruent, this face is congruent to this face. It's the same. The top is congruent to the bottom, and the front is congruent to the back. Okay, we'll talk a lot about that when we're talking about surface area. Then the shape of this figure, this Kleenex box, as with the cereal box, that is our rectangular prism. So as we said, the cereal box has 6 faces. Each rectangular face is perpendicular to the 4 adjacent or next to faces, and the opposite faces are parallel and congruent. Congruent meaning the same. Edges, okay, so these are the edges. Okay, remember this is our face, okay, and then these are our edges. And the cereal box has 12 edges. Each edge is parallel and congruent to the opposite edge. Let's count those edges, okay? So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? And then the vertices. It has 8 vertices, that cereal box did. So those are those points, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, those are our vertices. And we said that's a rectangular prism. Okay, when we look at this shape, okay, I feel like we could just put a big old nice big thing of ice cream on the top, and it is a cone. Okay. All right, and so we'll have more activities that will help you understand more about 3-dimensional figures. Thank you.